Okay, here I am back up top, right? If you look over there, right, that little raised deck there, that is the roof of the pool house. So where I was just previously was down below the surface level of the pool inside a room underneath that deck there. So all of my pumping is actually below water level, which is a little bit different than most pools. Most pools have their pumping and filtration systems right on the deck level. But I have a slope in my backyard that allowed me to put everything below. Okay, so here's my fountain. So that 2-inch line that leaves the pool house is the fountain line, comes around the edges, the perimeter of the pool. It was installed before it was built, comes up along this wall, and then comes right along here, and I'm pretty sure it comes straight out, and then there's an elbow right here that sends it right up out. So there's a whole bunch of piping here that you cannot see. I have a bunch of photographs from when the pool was built that I will try to dig out and provide to you so you can get a sense, so you can estimate all of the fittings and the length of 2-inch pipe that is buried beneath the ground and can't see, but that you're going to need to account for. So normally my fountain has this little cap that's laying on the bottom, right? I pop that off, let it lay there so it doesn't get lost. And normally that's on right here. So this little union fitting here is gone and that cap sits on top. And this cap is just a cap that I drilled a little pattern of holes in, and it gives me my little dancing waters. And what I've done is I've actually added an agglomeration of a whole bunch of other elbows and 2-inch pipe and a little bit of 1.5-inch pipe, just to add some complexity to the system and make it a little bit more interesting, and also to make it so that I can actually collect water in a bucket and get a flow rate, right? So what we're going to do to get the flow rate is we're going to time how long it takes to fill a 20-liter bucket full of water, and that'll give us a volumetric flow rate. So I've added in here the union, which doesn't have much pressure drop, but it has a little bit. I have a tight 90-degree elbow, and again, this is all 2-inch PVC Schedule 40 piping. I have probably about 5 or 6 feet of pipe. I have another standard elbow, about 3 feet of pipe, another standard elbow, another 2 feet or so, and I'm going to take measurements of these and provide them all for you. So there's another elbow, another length of pipe, another standard elbow right there, another length of pipe. Here's a sweep elbow. So you can see this has a little more generous radius to it, a little more gentle turn, results in a little less pressure drop. I have another straight length of pipe, another standard elbow, and then you can see there's actually a reducer bushing right at the outlet of this elbow that reduces me from 2-inch pipe over here to 1.5-inch pipe here. So now I have a tighter restriction, and I'm going to have a higher average flow velocity through this last little bit of pipe. So I have another sweep L, 1.5 inch. I come over here, I actually stuck a T in there. So I put an 1.5 inch T, so it's branch flow. It's coming in here, and the flow is going to go up. This end is just capped off, so the flow doesn't go anywhere in that direction. So all my flow is going out the branch, comes up, makes another standard elbow, another straight length, standard elbow, and that's where I'm going to collect my water, right there.